Algebra 1 students, in this video today we're going to finish our study of word problems from Chapter 4. Okay, your heading is Chapter 4 Word Problems Part 2, and be sure and include today's date. Copy down your heading, please, Chapter 4 Word Problems Part 2, and be sure and include today's date. Now, let's jump right into this. We're going to be looking at two word problems today. It'll be a very short video. And most of your learning will come from doing your homework, so do it well. Check your answers and use the help video if you need to. Okay, I would copy this down, your notes right here. I would copy page 229, example number 6, so you know where it's coming from. And then here we go. You are parachuting. At t equals 0 seconds, you open your chute. Okay, at a height of 2,500 feet above the ground. At 35 seconds, you're now at a height of 2,115. Let's get a picture of this, okay? Here's the plane. You jump out. You don't pull your string right away. Right here at this point, you pull the string, and that's at 0 seconds. Alright, the ground's down here, and you are 2,500 feet in the air. Alright, now 35 seconds later you pull the string, so the blue point right here, that represents when you pulled the string, and that was 35 seconds later. Now you're closer to the ground. Now you are 2,115 feet from the ground. Okay, so what is your rate of change in height? Alright, so we're looking at feet, because we're dealing with feet, per seconds, because we're dealing with seconds, so we're looking at feet per seconds. Alright, so you were at 2,500 feet, now you're at 2,115 feet. So how much have you dropped? Well, let's subtract and let's find out. You've dropped 385 feet. Now you did that in how many seconds? Well, you started at 0, 35 seconds later, you're here. So you did that in 35 seconds. So now simply take your calculators, which you're allowed to use with word problems, and type in 385 divided by 35, and you will get 11. So your rate of change in height is 11 feet per second. Okay, now, about when will you reach the ground? Well, I mean, let's go back up here to your starting point right here when you pulled the cord. At that moment right here, when you were this high off, when you were right here, you were 2,500 feet off the ground. Got it? So you're 2,500 feet off the ground, and you're falling 11 feet every second. Okay, so 11 goes to 25, to 2230, to 2280, about 227 seconds approximately. This really isn't a very good problem, because we understand that when you pull the cord right here and your chute opens, you're going to fall a lot slower. Okay, in fact, if it actually takes you 227 seconds, it's not good. That would actually mean your chute did not open. Okay, but to answer their question, using this rate, it would take you about 227 seconds. Okay, alright, now, moving on, let's see here. Example number 4, okay. Now this is a pretty tough problem, so really pay attention, okay? You are an intern at a city planner's office, and you are asked to create a graph for a planning board meeting. They want the graph to represent different heights of a local river during a flood. You are given these examples to model the changing river's heights as it rises, and then the rain stops and it goes down. Okay, so really, guys, I mean, it's not super hard if you'll think, but you got to look it over and think about it. Okay, now, for the first 60 hours when it's raining really hard, here's the model of tells you how high the river is. Put in 10 hours for t, it tells you how high the river is, okay? Now it's a linear equation, so we just need 2 points to draw the line, okay? So here's what I'm going to do. I'm going to use my first and my last number because this equation here only works for the first 60 hours. It only works from 0 to 60. That's what this means right here, okay? T is greater than 0, less than 60. So I'm going to, for this equation right here, I'm going to substitute in 0. And if I do that, I'll get out 24. And then I'm going to substitute in 60. And if I do that, I will get, let's see, 60, 30, 54. Okay? So what that means is at 0 hours, that means it's not rained. The river's 24 feet deep. That's the normal amount. 60 hours later, it's 54 feet. Okay, so let's graph that real quick here. So we'll go probably in increments of 10, I would have to assume. Now students, my x-axis here is going to be in increments of 10, and my y-axis here is going to be in increments of 5, okay? So my first point is 0, 24, so 5, 10, 15, 20, 24. My last point would be 60, 54, so 10, 20, 30, 40, 10, 20, 30, 40, 50, 60, and then up to 54. So we're looking at 10, 20, 25, 30, 35, 40, 45, 50, 55, 60. So here's 60. So I have 54. So here's 54 right here. And then go over to 60 about right here. So there we go. So we simply draw a line like this. Do not put arrows, okay? Remember, it's a word problem, so we just go from 0 to 60. Alright? Now, let's use our next equation and look at this. It's a single variable equation. H equals 54. This is your, I put y, this is your h-axis here, because h is all by itself. This is your t-axis here. So remember, when you have an y only or an h only, it's going to be a horizontal line going through 54. So here's 54 right here, so I'm going to draw a horizontal line going through 54 like this. But here's the problem with that. Think about it, students. Now watch this. The horizontal line only exists from 60 to 72. Well, here's 60 on the x-axis. Here's 72 right here. So the line's only going to run from here to here. Alright, about right there. So the rest of this line we're not going to use at all. Not a bit. Okay, not at all. Now I really hope that makes sense, guys. Okay, look. This horizontal line, h equals 54, only works from 60 to 72, which is from here to about here. On the x-axis, no, it's not perfectly lined up, but you get the point, okay? Now, for this equation here, we're going to use 72 and 120, okay? So I'm going to put in 72 and get out a number. Then I'm going to put in 120 and get out a number. So if you put 72 in here, you would get a negative, let's see, 9, negative 45, negative 45, and 99 would be rainstorm that happened in 60 hours.